In this lesson, I will explain about the player script. This thing. Let's start from the top. So, at the top here, as you can see, there are a couple of other scenes and scripts I included. The Y framework. It is my framework. It's a couple of useful functions. I use things like for distance and rotation. I have one for 2D, but this one is more for 3D. The bullet is not needed. That's the bullet scene reference. Preloaded, I don't need it. I needed it when I tested, when I first started, and I have to create a bullet, but now weapon handles all that. All the shooting mechanism and logic. I'll show you a bit of it in this video. So the input control is which type of control the player uses, the keyboard or the mouse. The mouse didn't work out for now. I'll have to fix it later. It's commented out. So for now we use only the keyboard. Here, these variables are for what it says here. The response for maneuverability and speed. These values, either this one limits the maximum speed the ship can reach. This one is the acceleration. When you click to accelerate or decelerate, it will accelerate by this rate. The pitch speed is the rotation speed of the pitch. This one is for the roll and this one is for the yaw. If you don't know what's roll, yaw and speed, I found this nice image that will explain it. So the yaw is vertical rotation, like as it says here, like if I want to turn it left or right, and this one is, the roll is like what it is when the object rolls to the left or to the right. And then you have the pitch. It's for like if you want to get the nose up or down. Should take a look at this, read about it if you don't know what it is. I'll be surprised if you don't. So these are for the rotation speeds. Like some ships control faster or slower, they rotate slower or faster depending on reasons. Max yaw and max roll, I wanted to use it for the mouse control, didn't work out, have to fix it later. The input response is basically you multiply it by the delta. It's the rate of how responsive is the controls when you click them. Like I can do this a very large number, and when I click up, it will drastically move up or down. And if I put it as a lower number, it will react slower when I click. These and this and this correlate a little bit. I'll show it to you. Actually, let's show it to you now. Ctrl+C, Ctrl+F. I don't use it more than 2 times. So that's the keyboard movement function. It gets the delta from the main game loop. So here it uses the interpolate function. Godot calls it lerp. To lerp between the pitch input. I'll show it to you now. What the pitch input starts at 0. Let's see, where was it? Here. And then you interpolated. The second vector is the strength, the action strength of pressing pitch down, which is the button S, minus the strength of pitch up, which is W, when you click W. And then you, its weight or rate, as I call it, is the input response, the 8.0 multiplied by the delta time. Okay, so let's show you how interpolation works. You might be new to Godot, you might don't know what interpolation is. So Godot has a very good explanation of this. I wouldn't try to understand this equation. I would look at this one. It's basically the first vector plus the second vector, the difference between the second vector and the first vector multiplied by the rate or weight, as they call it. So what this does is a twin-like effect, easing or twin, if you ever used Flash. That's how they use it. The first vector, second vector, position. It's position vector, a 3D vector, and the rate at the end. And all this, what it does is basically this math function. It's very simple algebra. You don't even have powers here or division or anything. And what this does is move it by kind of a percent of the difference between the b minus a plus the b minus a multiplied by the rate, and it does this. It can be used for global positions, global transforms. What they show here are actually global transforms, positions. They call position. It's 3D. It's also a position, but as you can see, it has a rotation, so it interpolates between also the XYZ position and the XYZ rotation. As you can see here, the monkey head moves, but it rotates with the interpolation. Here they, do as I said, the transform. Unlike here, where they do the position, interpolate position, here they interpolate the transform itself. And here they have another practical example of movement with easing using LERP. Reading about it won't help you much. The best thing to do is to open a project and try using it to do stuff, or find examples of what it does until you get a feel of what it does and understand it. They write here in a very technical language, like a university, or like they're writing a paper for a university or something, or for a math book. This is the documentation for the vector3 class. We are at vector3 method LERP. So the vector you wanna effect with the LERP is here, like you put whatever vector.lerp, and here you put the vector you wanna lerp it to, and by the weight or rate. Let's see what they say on weight here. Weight is on the range of 0.0 to 1.0, basically percents, from 0% to 100%, representing the amount of interpolation. So what we do here is we interpolate from, at the start, from 0 to whatever this value is. It's not a vector here, these are two numbers, and we interpolate this number and the number we get from here, from the strength of the pitch up and minus the pitch up, by this rate, the input response multiplied by the delta. The delta is also a decimal, so it will reduce the 8.0 to a much smaller rate. So the pitch, they move up and down, move the player ship up and nose up and down, rotated up and down, is determined partially by the pitch input and partially by the pitch speed. And the same is for the roll. When the roll, the Y rotation, and we use the transform to change the rotation. We use the transform basis. I'll explain about the transform basis in a second. I just want to show you the whole thing. Transform.basis.rotated. Rotated is the function we use. We must normalize the x vector. It's the I'll explain to you in a moment what this vector represents. You must normalize it. We don't want the length of the vector, we just want its direction. And then you add to it radian, which is the pitch input, the player's input, multiplied by the pitch speed, multiplied by the delta. We have to multiply by the delta, so in case different PCs have different CPUs, this prevents different speeds and responses between different computers. That's the gist of what the delta does. You need to read about it. It's very simple. It's basically the time between the last loop. let's show you transform basis thing. So in Godot, they call the representation of positions in 3D and rotations, and they call them transform. So the basis is a matrix containing 3 vectors of vector 3. It's basically a 3 by 3 vector, as its columns x, y, and z axis. These vectors can be interpreted as the basic vectors of local coordinate system traveling with the object. As I said, they explain it in a too high language. It's like, it's good for university if you're writing a paper, but for dumb game programmers, like, you need to assume the person that is reading this is dumb, or that you can even explain this to a dumb person, because it can be done. I'll show you now. So the basis, right? It's a 3 by 3 vector. So it kind of, what they say here, as they say it, x, y, z axis, interpreted as the basis vector of local coordinated system traveling with the object. Doesn't say much, but I'll show you now. Let's go to the player. So let's say the z part of it, the z part of the basis is what points forward. It's a vector that points forward. I think it's normal. Well, it's the vector that points forward from the object, not from the model, from the what they call the transform origin, which is this point here. There, where you see my mouse, it's this thing. The green one is the y, blue is z, and x is the red. So, as I said, so z is a vector pointing forward from the origin, the z basis.z. The y points up, and the x, I think it points to one of these directions. I know that the z is the forward vector, and the y is the up. This is very effective if you want to change the rotation of the object. In fact, we actually use it for rotating the object. We get the transform basis and we apply a rotation to it using rotated. We get the normalized version of the x rotation, you know, to the pitch of the ship, and then we apply to it this radian. They actually don't say it's a radian, but it's a radian. It's not an angle here. And when you look at the basis, the documentation of the basis, and you go to the rotated function, they tell you introduce additional rotation around the given axis by phi. Oh, it says it's radians. Nice. Only relevant when the matrix is being used as a part of transform. The axis must be a normalized vector. So, as I said, the axis you want to rotate it by should be normalized. And normalization, I also, just in case you don't know anything about 3D math, I search for normalization vector for dummies. To normalize a vector, therefore, is to take the vector of any length and keeping its pointing in the same direction changes its length to 1. Not only 1, it can also be -1 or anywhere between. It's like the direction in... You should read about it. Since it describes a vector direct... Yeah. Without regards to its length. Yeah, as I said. About 3D math, I'll give you the simple version. It's nice to learn it. It's nice to learn the equations and all that, but in programming, you use it for a practical application. You actually move stuff with it. So if I were to learn 3D math from zero, how I learned it actually, is by trying to do something, searching for example code and playing with that code, like trying to break it, like if I wanted to learn about the basis, I would take its values and start playing with them and see what happened. Like I'll go basis.x.something. or maybe it's an array. No, it's a vector tree, and you can get its first or second or third value and start playing with it and see what happens. And same with the rotated. That way, when you play with these things, you start to intuitively understand what they do. And then when you read about them, like, oh, it's a radian, it's not an angle, or whatever, or when you read this nonsense, you can explain it like I explained what the X, Y, and Z does. Like, if I ask you what this, in a generally what the Z-axis of the basis means, of the 3x3 vector, you'll get a 3 vector. It's basically the forward vector of the origin. The origin, the translation offset of the transform. They have also a global transform. It's the same as transform.origin. It's basically its global position. I showed you. What's the origin? Where is it? This thing here. This point, exactly. I don't remember how they call it. The offset? Offset, I think that's the name of it. In Flash, in 2D, they also had a 2D offset of the object. Its position in the world, in the screen. Here it's in the world, not the screen. So yeah, you'll have to play with it to understand it. Maybe you just wanted me to continue and you understand this already, or you programmed something in 3D, but that's what it does. Use rotated on, let's say, the X basis, and you use the pitch input multiplied by the pitch speed to change its rotation, and multiplied by the delta, of course. And you do the same for the roll, the y vector of the basis. It has 3 vectors x, y, z. And we also use the z of the basis to move the ship forward. I'll show it to you now. It's very simple. Velocity is minus transform z. That's how it worked. When I look at it, can you tell which one is actually forward or backward? Like, I have a vertigo by only looking at it. So I played with it. The minus worked. Yeah, there's a lot of code in Godot that actually shows this exact thing. The z basis multiplied by the forward speed, or speed, and then you use move and collide, Godot move and collide, and give to it the velocity multiplied by the delta. And this is what moves the ship forward on its forward z vector on the basis. As I said, the z is like forward vector of the 3D object. You should play with it and you'll see what it does. And I used the Godot function here, like if you use physics systems in games, you'll see that if you try to change their rotations and positions by yourself, the physics system, like, and you use the physics system at the same time, it says like, no, that's not the position, that's the position. It fixes it. It overrides your changes, basically. So here I went with the Godot's. Well, I don't really need physics for this game very much, because it's arcadey style. You don't need too much physics for this game. So that's how it moves forward, by the forward speed. Let's go here again, the keyboard movement. I think we're finished with it. I explained everything. If you don't understand any of it, like if you have a little experience with 3D and 3D programming, you should be able to get it. If you don't, the Godot itself has a ton of resources in its API, its transform, its basis. It's yeah, this one is about using transform. Shows the it even talks about theory and shows you how things go wrong. Yeah. And yeah, matrices and transformation, in case you don't understand what is a 3-on-3 vector. It's not very hard to understand. I learned it. I wasn't a very good math student, and from doing game development, well, actually, I saved this one for you too. if you want to learn about linear algebra for game developers, this is one of the best resources there is. They show you visually how it does. It has 3 parts, and you don't need much more than that. It's called blog.wolfire.com. I'll leave the link in the documentation somewhere, but you can also see it here. Linear Algebra for Game Developers Part 1 in Wolfire. It's enough to search for it on Google. So yeah, this video is not about teaching 3D math, it's about showing my code. So let's move on. So we know what this does. That's for the adds to the rotation speed. It's multiplied by the pitch input, which is interpolated between the pitch input itself and this value. It's the weight of the interpolation, and the second value for the lerp is the power of the input between the 2 inputs, like up or down, left or right. I showed it here. I'm talking about this code. Moving on. Velocity. It's I showed it to you. Basically, Godot increments the velocity value, like this vector by here it adds this to the global transform of in Godot. So most objects will have velocity in case you want to calculate stuff with them. So that's the velocity. Forward speed is like if you press R, it will increase the forward speed by this rate, by acceleration, or F to decrease it. So this here is what gets added to the velocity every tick of the game. The camera is a reference to this 3D object. Here, the camera, the main camera I use. Not used, I think. The team is the player's team, like it determines, it used to determine if like a ship is a friend or foe by the AI and the bullet and everything. So the player's team is team 1, the enemy's team is team 2. Target is the current ship's target. It will use to to pass it on to homing missiles and stuff, and it's also used for the red pointer, this thing here, that points to the target. I'll add functionality for alternating between targets in case you want to change targets or aim at different targets, mostly fighters, or I'll let one of the contributors do it. It's not very complicated. Here, the only thing I do in the init in ready, I add it to the player group, and to the main weapon I pass this object, the player object, as that. So it can reference it if it needs any of these attributes for any reason. Maybe it needs the target or the team, to pass the team to the bullet. So we pass self to the main weapon in case it needs any of these attributes or methods. Point to target is what points this object to the targ, to the target attribute. Target attribute is short for target. Next, in get input, which is also in the physics process, the update function, it determines which controls is used, mouse or keyboard. In our case, we use keyboard. Mouse is functionality is commented out. Here I commented it. It's commented out. And for the acceleration, if input total up R or F is pressed, you can see it here in settings input map. It's down here. You have total up and total down, R and F, and all the other inputs we use. So forward speed, for forward speed we use lerp. We get the base forward speed, which should be 10 at the start. The shift speed, it starts like when you enter the level it has a speed already, like you're not standing in place. So it's 10. So we interpolated between the maximum speed, it can't go over the maximum speed, by the rate of acceleration multiplied by the delta. And the acceleration, let's see, the acceleration is 2.3. So if you want to make the ship accelerate faster, like to reach its maximum speed faster, you'll make this a bigger number or smaller depending on reasons, gameplay reasons. C compares target speed. If you press C and the target is valid, of course, it will basically set forward speed to the target speed. Most targets should have a speed variable, so it shouldn't return an error, and the forward speed can't be more than the maximum speed. I should make this an interpolation function for this, but I want to make a fast fix. In the X3 game in the series, they have a way to compare your ship speed to the target speed for aiming purposes, so I just added this function. The shoot mechanism is this. That's it. If main weapon can shoot, and you pass to it delta, because it uses delta for its timer, loop all the guns. For each gun in guns children, it's basically the guns are here at the front of the ship. Here, these are two 3D points. It's where the bullet is created. Like for each gun, it creates a bullet. For each gun, main weapon, make a bullet, gun. Let's go to weapon and show you what can shoot does. Can shoot, it has a timer. That's the logic of the timer. It adds the delta, and if the timer counter is bigger than the timer's value, it returns true. And it also checks if you pressed fire, like the mouse click. If it does, reset the timer and return true. Basically, if you click shoot and the timer is not done, the fire rate timer is not done, you won't be able to shoot. And make bullet creates the bullet. It puts it on a variable called b, the bullet.create instance, and you add the bullet to the world, like you get that. That is the weapon's parent, the player's ship, and it calls the owner, which is the level, and add to it the bullet. I wanted to add the bullet to the level, not under, let's say, player here, under this. Let's see. So we're in weapon, and I changed the bullet global transform to the gun. You know, when you make a bullet, you pass to it the gun that shoots the bullet. So it changes the global transform, basically the position, the rotation, and even the scale of the gun. It passes it to, basically sets the global transform, the transform dot origin of bullet. It sets it to the global transform of the this position here, the front of the ship, or the second one. And I also reset the scale of the bullet, just in case. The bullet speed, I set it to the gun's bullet speed. Like each gun shoots bullets in different speeds, so the bullet speed is saved here, in the weapon's attributes. And I also pass to it the weapon's damage. I pass it to the bullet, and the bullet's team is the player's team. We get the team of the player from that, somewhere around here. So the team is basically 1 by default, but in the enemy I set it to 2 or to its team, depending if it's an ally fighter or an enemy fighter. And then it returns the bullet, so we can manipulate the bullet here if we need to manipulate it for any reason. Take damage, not used. Keyboard movement, I showed it to you. Mouse movement, not used. Point to target. Basically, this part gets the target. This part makes the red pointer target / try, which is this here. You see? Try. and it rotates it to the global transform origin of the target tag. So the way it selects the target, it loops all the enemies. Get by type gets all the object types of the second argument. The first argument is the object calling it. Second one, basically get all the enemy objects. If there are you have more than 0 enemies in that list, make the target indicator, the red thing, visible, and make it look at the first enemy. Global transform, and you need to put a vector up here, or whatever your default app is. App is basically 0, 1, 0. You should take a look at the function in the documentation if you haven't used it yet. If there are no enemies or anything, make it not visible. And here it also tells it to look at, that's why I need to separate these to first find the target. So if there is a target, don't run this. I just wrote it out of my head at one sitting. I just wanted the whole functionality at once. I need to, or maybe one of the contributors will just refactor it. It's very easy to do. So basically, if we want to look at the target, we first make sure the target is not null. It will be null once you destroy the target, or you don't want to lock on a target. This needs to be set to null. And if there is a target and we removed it, we need to make sure it's a valid instance. Like if it's removed, it's not a valid instance. So we want to only target targets that are in the game level, the game scene, the level scene. If it does, target 2, the red thing, the red arrow, look at target, global transform origin, blah blah. Yeah, and that's what it does. Not used, as it didn't work. And this is the normalize function. It basically gets the vector, normalizes it. If it's 0 or basically below 1, reset it, and then return the new vector. So yeah, that's what all the player does. All this code is for shooting mechanism, which is handled by weapon, and all this is mostly for the movement and functionality for the point to target function that handles this thing here. That's kind of it. If you don't understand the 3D math, it's not hard. It's not hard to learn about this. You don't even need to use the Godot documentation. You can read about it. The Godot documentation is not bad. The best way to learn 3D math is to play with it. Play with it until you get it on an intuitive level. That's the best advice. And that's it for this lesson.